Hello, in this video, which addresses applied survey research, we will discuss data analysis and reporting when conducting a correlational study. We'll first define what correlations mean. We will discuss the research process of using surveys to do a correlational study. We'll discuss assumptions, P&R values, effect size, reporting, and then finally practical application. First off, what are correlations? What is this idea of having a correlational design to a research study? There's the methodology, which a correlational study basically means that you are going to examine the relationships between variables. You cannot claim causation, but you can look at that relationship between your variables. Also, correlation analysis can refer to the actual statistical analysis of your study. The research process is you begin with the item and scale design. Perhaps you're using a published measure. You create a survey, administer it. Once you get your data collected, you clean and screen the data. Once that's ready, you may do that in statistical software. I prefer using Excel to clean and screen my data, and then I'll move it over to a statistics file. Then you examine outliers, which is basically the last type of screening you will do, because you may find that you have outliers that were the result of, for instance, unreliable data, and so you will remove those that data for the various participants that may have unreliable data. You may also keep the outliers because it appears that the data is reliable, and that's just a normal part of the sample. Once outliers are examined, then you go on to descriptive statistics. Then you look at assumptions of a more advanced statistical analysis that you want to make. If those assumptions are met, you choose your statistic. If not, then you may move on to an alternative. Then you perform your analysis, and finally you can make inferences and report the data. So what are assumptions? Well, for the purposes of this video, we are going to look at Pearson correlation analysis. I highly recommend using Laird Statistics. I have the address right here, which can help you better understand all sorts of statistical analyses. And in this particular example, you can look and see a detailed description of the assumptions that need to be met for Pearson correlation. The 5 assumptions that need to be met. First, you must have 2 continuous variables. In the example that you see in front of you here, the image with the scatter plot, it's looking at anticipated discrimination and the correlation with day-to-day discrimination. Those are both continuous variables. They must be paired. In other words, the data was collected from the same participants in the same study. In other words, one participant was scored on their experiences with anticipated discrimination as well as day-to-day, so it was paired. There must be a linear relationship between the variables. This scatter plot reveals that there is a relationship. You must have no significant outliers. A box plot can help you examine outliers. And then finally, you must have bivariate normality, meaning you must have somewhat of a normal distribution. Shapiro-Wilk, Kolmogorov-Smirnov test can determine whether you have a normal distribution or not. So what are P&R values? Well, first off, the first statistic you'll look at is your p-value to determine if you actually have a statistically significant relationship. Oftentimes in studies, a p-value or an alpha level of 0.05 is going to be acceptable, so anything below that value will be statistically significant. What that basically means is that there is only a 5% chance that the results of your study are due to chance. Oftentimes for other types of research, let's say in a medical industry where maybe you're testing some sort of new medication, p-value may be at 0.001. That way there's only in that case there's a very slim chance that it's due to chance. So that whatever you're testing is actually what's contributing to changes in the variables that you're exploring. And then finally, once you've determined that you have a statistically significant relationship, then you look at the R value or the effect size. And the effect size, the higher the value, the greater the effect. For Pearson, if the value is 0.1 in that area, you have a small effect. If it's 0.3 and higher, then you have a medium effect. And then finally, if it gets to be around the 0.5 range, you have what's considered a large effect. In the example here, the R value is 0.648, meaning that is a large effect. When reporting the information, there is a preferred way of reporting, which includes the degrees of freedom, the effect size, and the p-value. There's examples in front of you here, and I will show you here an example right up. Basically, we're stating that the results showed a significant positive relationship, meaning the variables, when one variable went up, the other went up, or when one variable went down, the other went down. That's a positive relationship. They both go the same direction. So results showed a significant positive relationship between information overload and work interference with personal life. And the p-value is 0.021, therefore was statistically significant at an effect size of 0.372, which would be a medium effect. And then between information overload and personal interference as well. And then in that example, because the p-value was below 0.001, we put p is less than 0.001. If it's higher, then you put the p-value is equal to the actual value. Practical application of correlational analysis. The example you have here, let's suppose in the workplace, you want to figure out how to increase leadership capacity, perhaps leadership, the ability for individuals to be leaders and more effective leaders. And so perhaps you measure the amount of resources, or it could even be the budget that's the amount of resources and budget that's being put towards, let's say, leadership development. You may also look at the potential of the employees. Perhaps you're measuring their leadership style. You're measuring some other sort of characteristics of leadership. And then finally, you're looking at support. Support could be, for instance, how engaged managers are, or again, you could look at resources. You could also look at feedback methods. However you measure those, as long as they're measured with a continuous variable, then you can look at correlations between those things to see if they are correlated with increased leadership capacity. Then if so, if for instance you have, let's say, a large effect for resources, but maybe potential is not even significant, because anyone can be a leader, so it's not necessarily they have to exhibit certain, let's say, management characteristics, for instance. So if resources has a high effect, potential there's not significant, but support, again, is significant, let's say with maybe a low effect, well then you can perhaps make a decision that it's most important to increase the resources first, because then that will, according to the study, will increase leadership capacity, but then also secondarily focus on support mechanisms. I hope that helps you better understand correlation analysis.